Good morning. This is now Thursday, and as I said, I'm just kind of following up on some questions I got, and I'll put this out as a video for you guys, and then like I said, I'll put the full answer key out tomorrow. So first one I had a question on was the 1C. So again, we're trying to calculate the coordinates of x-intercepts, then we're looking for turning points, whether that's a min or a max, and then listing where it is decreasing. So with the function in C, 3x squared plus 2x minus 5, it's already factored out for us. So to find the x-intercepts, I'm just going to set each of those equal to 0. Here you just have to add 1. Here you're going to subtract 5 and then divide by 3. So those are your x-intercepts right there. -5/3, 0, and 1, 0. Okay, now for finding the turning points, you really do want to use a graphing calculator. Although in this case, if you kind of think it through, we're talking about a x squared polynomial with a degree x squared, which makes it a parabola with only one turning point, which is the vertex. So you could actually solve for it algebraically just by finding the vertex. But let me see if I can do this for you without driving you nuts. But there's what we're looking at for the graph, right? So that is a parabola, and it does have just the one turning point, which makes sense, right? It's a degree of 2, so one turning point. So you could actually, in this case, search for it a couple different ways, but kind of the method we were using, since you can see that that is a minimum there, okay, we're going to search for that point as a minimum. And again, I know you guys don't have these calculators. Do the best you can with whatever you have available and make that work for the time being, okay? So there's your minimum. You get the little yellow flag on these calculators, and there it is. So I think I can snap that. Quit shaking the screen for you. Okay, so really that takes care of kind of the part B that they were asking us to do. All right, because you have right there, if it'll let me write on it, right there is your only turning point, and that is a local min. In this case, it is the minimum overall as well because you're talking parabola, but we'll kind of use the language in this problem, so that's a local minimum. And then the last thing they ask us to do is, where is this function decreasing? Well, again, when you're talking increasing, decreasing, you're talking about the function value in relation to your x value. So if I'm tracing this graph, I am going down right now as I'm moving left to right. So when my x values are anywhere from -infinity up to -0.33, then I am decreasing. And then once you hit that turning point, now you're increasing. Okay? So D, similar process, right? We want to first set each of those factors equal to 0. And it's already written in both factored form and standard form. Here subtract 4, here add 2, and there is your x-intercepts. And then bear with me again here, I got this graphed somewhere, I think. Okay. Okay, so there's both of them. I think I can get the first one off here. All right, there we go. So there's just the 1/2 x squared plus x minus 4. And that also is a parabola. Okay, so we're going to be following a similar process with this calculator. That is also a minimum. So I'm going to be searching for that minimum. Make sure you cover the area that has it. And there it pops up for us. Got a little muddled there with the other one, but drag that out for you. And there you go. So -1, -4.5. Bear with me here. I'll get this a little bit cleaner. Okay, and there you have it. So we're talking about that as a parabola. So the minimum is the vertex. It's right there. -1, -4.5. And then when we want to talk about where this function is decreasing, again, if you're tracing it, it's going to be decreasing when your x values all the way from -infinity up until that turning point at -1. So that's where it would be decreasing. Okay, so there's 1, C, and D. The next question that I think came up that people got back to me was for 5B. And here we are solving for the roots of each function. So roots, x-intercepts, solutions, you're really all kind of talking about the same thing there. So we want to factor. So we're going to set that equal to 0 and then factor. So, oh, I see. So I think this is probably why we had a question. This one, if you try to do diamond problem generic rectangle, not going to work. So you have to factor this one using completing the square. So this was a good question. So remember, to complete the square, we're first going to kind of make sure we have a coefficient of 1 with x squared, which we do. Then you're going to add that 13 over. And then we have to make that a perfect square trinomial. So you're going to take your b divided by 2 and square it. In this case, that's 8 divided by 2, which is 4, squared is 16. So you're going to add 16 there. You also have to add 16 to the other side. That's 29. This now is a perfect square trinomial, so we know it's going to be that value. Squared, take the square root on both sides. That's plus or minus the square root of 29 equals x plus 4. And then subtract 4 from both sides. -4 plus or minus the square root of 29. And there you go. That's completing the square. So that one kind of forces you into either completing the square. If you wanted to do it with quadratic formula, that would also work. And I'm okay with you guys solving it either way. So that x equals -b plus or minus the square root b squared minus 4ac over 2a. That would also work. Okay, 6b was the next one. And here you are trying to get from quadratic form into vertex form, which also means that we are going to have to use completing the square. So, first want to deal with that 1/3 there. Okay, and really you can add over the 3 first. So let's make that y plus 3. And then you got to factor out a 1/3. Well, 1/3 x squared divided by 1/3 is obviously just x squared. 4 divided by 1/3 product of the outside over product of the inside is actually 12. So you're looking at that. And then we're following the same steps that we just did in 5b. So you want to take your b divided by 2 and square it. B in this case is now a -12, which would be a -6. Squared is a positive 36. So that's what we're putting in there. Now, one of the kind of tricks, and why this is a little bit different than when you're solving, is when we're adding 36 inside the parentheses on the right side of the equation, you're actually adding a value that is 1/3 times 36, which would be a positive 12. So you're going to add 12 over to that side. So you're now looking at y plus 15 equals 1/3. And we know this is going to break down to that factor, so x minus 6 squared. No need to take the square root on either side here. You're just going to subtract 15. And there is your vertex form. That gives you a vertex at positive 6, negative 15. And there's your kind of two answers that they're talking about right there. Now, if you go all the way back to where we started pretty much the year and look at that, kind of break down that graph, and you got a vertex at 6, negative 15, and you are looking at a vertical shrink of a factor of 1/3. The down 15, right 6, or just use the vertex, but you could get a quick sketch of that too. So just kind of tying back to what we really started the year with. Okay, where else did we have? And then 9b was another question here. So we're trying to determine whether these functions are even, odd, or neither. So remember, we're testing it for f of negative x, which means you're going to substitute everywhere you have a positive x, you're going to substitute a negative x. And then when we simplify this, well, negative x to the 7th power is still a negative x. So that's going to change that to a positive x to the 7th. Similar here, a negative x to the 3rd power is negative x times the negative 5 is a plus 5x. The 4 is unaffected. So what you end up with here is the first term has gone opposite. The second term has gone opposite. That should still be the 3rd, sorry. Second term has gone opposite, but the 3rd term has just stayed the same. So if all of them had switched to the opposite sign, that would be odd. If none of them switched and they all stayed the same, that would be even. But in this case, since we have some that changed and some that didn't, that is neither even or odd. And I think that was it as far as the questions. So obviously that's not the end of it. If you guys have more questions than that, feel free to send me an email with a picture of your work if you want. I'm also trying to check Google Classroom if people put messages there. And then again, I'll put the key out tomorrow. Make sure you take pictures of your work and show it to me by Monday evening, and I'll start entering those in on Tuesday. And then guys, you just got one more assignment left after that, and we'll call it a year. So hang in there, make it worth your while, get a little bit more work done here, and then feel good about it, hopefully going into